can react with metal aqua ions to form metal hydroxide precipitates and ligand substituted metal aqua ion complexes. For example, when butyl amine is added dropwise to a solution that contains copper 2 plus ions, Cu2 plus, a light blue precipitate forms. If then added in excess, the light blue precipitate dissolves and a deep blue solution is formed. Aqueous metal ions form aqua complexes that are made up of the positively charged metal ion surrounded by water molecules acting as ligands, in which oxygen atoms in the water molecules have formed coordinate, dative covalent bonds to the metal ion. When small amounts of an amine are added to water, the amine acts as a base and hydroxide ions get released, making the solution alkaline, as we saw earlier in this video. If this happens in a solution with metal aqua ions in, the hydroxide ions now present in the solution end up taking H plus ions from water ligands around the metal ion, leaving them as OH minus ligands. This happens until the whole complex ends up becoming neutral overall. At this point, it is no longer able to dissolve in the water and ends up as a metal hydroxide precipitate. Sometimes, however, if more amine gets added, ligand substitution reactions can occur, and amine molecules end up becoming ligands attached to the metal ion. The nitrogen in an amine is able to use its lone pair of electrons to form a coordinate dative covalent bond with the metal ion, and replace a ligand already bonded to the metal ion. As amines have no charge, they are neutral ligands, and this means the metal aqua ion complex ends up with an overall charge again, the charge of the metal ion itself. And this means it dissolves back into the solution. In other words, the precipitate formed when small amounts of amine were added redissolves again when excess amine gets added.